Hello everyone, I'm Aylin. Just like every Thursday, we are here again this week with a new topic, which is conventional fire detection systems. Yes, we have two system types for fire detection, conventional systems and intelligent addressable systems. So fires are one of the most significant risks threatening life and property, and early detection of a fire is critical to preventing loss of life and also minimizing material damage and ensuring effective emergency response. Therefore, fire detection systems are indispensable safety elements of modern buildings. So conventional fire detection systems are reliable and economical solutions that detect fire signs and alert users audibly and visually. And detectors and manual call points are grouped into specific zones, and the zone where the fire occurred can be monitored via the control panel. And these systems, preferred especially in small and medium-sized scalable buildings, maintain their importance today due to their easy installation and also low operating costs. So this presentation will cover the working principles, basic components, advantages, areas of use, and application principles of the conventional systems. Yes, as you can see, in a conventional fire detection system, detectors and manual call points are connected to the panel in specific zones, and the system continuously monitors the connected detection devices. And when a detector senses smoke or temperature increase, or when a fire alarm manual call point is activated, an alarm signal is sent from the relevant zone to the fire panel. And the panel identifies the zone from which the alarm originated and reports the fire situation. So this informs people inside the building with audible or visual warnings and initiates the necessary emergency procedures, such as evacuation. Furthermore, thanks to the end-of-line resistors, the 6.8 kiloohms, the integrity of the zone line it is continuously monitored. So faults such as cable breaks or short circuits are detected by the panel and reported to the user because of the end-of-line resistor. Yes, here is the normal case connection example. So, in conventional systems, the resistance value, the end-of-line resistors, measured at the beginning of the line, and it is normally measured as the resistance value attached to the end of the line. So that is the line resistor and the end-of-line resistor are equal, and this represents the normal case. So this is the operating principle of the normal case. And then line short circuit case. So in the event of a short circuit, here as you can see, in the zone line, the line resistance is measured as 0 ohms. In this case, the faultlet for the relevant zone on the control panel eliminates. So this is the short circuit case. And we have the open circuit case. So within the operating principles of the conventional system, it is possible to monitor line breaks. So when a break occurs in the zone line, the resistance value measured at the beginning of the line will be infinity. So the faultlet for that zone in the panel will light up and gives a warning. Yes, in a fire case, in the event of a fire, the detector alarm resistor is activated and causing the equivalent resistance of the zone line to decrease. So the resistance value measured at the beginning of the line will be between 2 ohms and 1 kilo ohms. So due to the increased current resulting from the decreased resistance, a fire signal is sent through the zone line, and the fire alert for the relevant zone in the control panel will then illuminate. So the fire signal is sent to the panel and gives an alert in conclusion. So the other principle is alarm status indicated by the manual call point. So the last one is the detector case, and this is the manual call point case. So in the event of a fire, the fire alarm manual call point is triggered, pressed, and causing the alarm resistor to activate. So thus the reducing the equivalent resistance again of the zone line, the alarm will occur. So the resistance value measured at the beginning of the line will be between again 2 ohms and 1 kilo ohms. And due to the increased current, again, a fire signal is generated. Therefore, in conventional systems, the source of the fire can be identified zonally, because the source of the fire alarm can be identified zonal, and its use is not recommended in high-rise buildings or projects with separate compartments, such as hotels, hospitals, universities, etc., etc. Yes. Yes, here is the conventional systems design example, design illustration. So, in conventional systems, each building should be defined at least one zone, and the building must be divided into detection zones. And this allows the alarm's point of origin to be quickly identified, especially. And then, in conventional systems, the largest zone area should not be over than 2000 meters squared. 2000 meters square is the maximum area. Then, in conventional systems, the floor area of a single zone should not exceed just a single zone. And we have, in conventional systems, each story, each floor should be at least one zone. So each zone should be limited to a single floor of the building. And then we have the total habitable floor area of the building should not exceed 300 meters square. Yes, points to consider during the system installation process. So first of all, accurate project design and planning. Detectors, manual call points, sounders, and cable placements should be planned according to risk analysis and standards, as you know. And then selection of suitable products and materials. So products should comply with the EN 54 standards and be selected to meet the project requirements. These are important ones. And attention to detector placement. So the standard says that detectors should be placed considering the ceiling height, environmental conditions, and coverage area. So as an example, the smoke detector's placement is like this. It's 6.2 meter, and the distance between the two detectors is 8.8 meter, and the wall or obstacle should be 4.4 meters. Yes. Prevention of false alarms. So mount detectors away from steam, dust, smoke, or excessive heat or rapid temperature changes and airflow that may affect the detection. These can affect the detection, and false alarms occurs, and we should prevent these type of fault signals. So cable routing and zone planning. cables should be selected according to cross-section zone boundaries, and zone boundaries should be clearly defined and short circuit or open circuit risks are prevented. The sixth one is cable routing guidelines. So cables should be routed inside the ceilings or conduits protected from the mechanical damage. And then control panel installation. The control panel should be accessible, visible, and adequately ventilated and protected from the environmental factors such as dust or heat, steam maybe. We should protect these panels. And the other eighth one is system earthing and power supply. So it's the most significant one maybe. Proper earthing for electrical safety and should be provided, and continuous power supply such as UPSs or sufficient battery capacity should be planned. So the power should not be cut off, and the earthing is the most important one, so be careful about that. And testing and commissioning and labeling, these are the last processes, and this says that all detectors, manual call points, sounders, and zones should be tested. So all devices and cables should be labeled, and test results should be recorded to prevent some kind of mistakes. And the last one is user training and documentation, of course. So users should be trained on system usage and emergency procedures, and project documents, diagrams, and user manuals should be delivered for evacuation, for emergency situations. So, in conclusion, with proper installation, regular maintenance, and testing, conventional fire alarm systems ensure the highest level of life and property safety. Yes, application areas. So we can use the conventional systems in residential buildings, such as two-storied buildings, or educational facilities, the small ones, of course, and commercial buildings, such as a shopping mall in a shopping center, and industrial facilities maybe, if there is a small area, if there is a needed about the conventional system, or the storage areas, of course. So conventional systems are an ideal fire detection solution for many small and medium-sized buildings. So the key point, the key word is small and medium-sized. And thanks to their easy installation, low cost, and flexibility of use. Yes, as a result, conventional fire detection systems are reliable fire safety solutions that detect signs of fire, trigger alarms, and identify the zone where the incident occurred. And they are widely preferred, particularly in small and medium-sized buildings. So due to their economical design, easy installation, and operation advantages. So for the system to function reliably, it is crucial that the design, equipment selection, and also zone planning. The other important one is cabling, and commissioning processes are carried out in accordance with the relevant standards, EN 54 standards. So these are supported by regular maintenance and periodic testing, of course, and conventional fire detection systems contributes to rapid response in fire situations and helping to protect lives and property. Yes, that's all for today. Thanks for your participation. Next week we will be meet again at 11 a.m. See you.